Thanks. Oh, that's not easy. Yeah, that's a new M1 and kind of a bit not working as expected. But anyway, thanks God, all is fixed. Thanks a lot for having me today. That's my first in DC. I'm very excited, actually. So many people, like, it's actually a bit scary, but I will try to do my best. So, going real time using Azure Cosmos DB and React. Obviously, we're going to talk about Azure services as SignalR, Azure SignalR, Azure Cosmos DB, Azure Functions, a bit of React code, and demo in the end. Unfortunately, didn't work out from the same reason because it's a new M1 and I didn't manage to properly transfer all my data. So, but I have screens, so you will understand what is supposed to happen. Couple of words about me. My name is Olena Borzenko. Once again, you can find me on Twitter. If you have any questions, please feel free to connect, or comments, or maybe feedback. I would be happy. And today is my first day in a company called Xspirit, and I'm very happy. I'm gonna open a bottle of champagne and celebrate it later on. So first in DC, first day in the company. So yeah, I'm very happy about it. And in the abstract for my session, in the description for my session, I was talking about monitoring systems. So first of all, I want to say a couple of words. What about our use case? So what I will try to show during the demo. I was working at some point in a product company where we were basically selling beverages. So we had the warehouses and with all the products inside. And for us, it was very important to understand how the movements of articles are happening inside the warehouse. Because they are driving the physical process, and this is the great way to understand the state of our warehouse or inventory. So inside the warehouse, we have movements of articles. When we have, for example, our articles arrived in the warehouse, we have inbound movement. When we moved our articles to the specific shelf, or maybe picking shelf, or maybe the packaging stations, it's every time there's event happening, which is a representation of a movement from one location to the another location. And based on this information, we can calculate our stock, and we can also display information for the warehouse. We can also have many different basically views and projections of our data, of our movements. Depends on how we can aggregate it, how we want to see it, or maybe what our clients need. And in our case, in my demo, in this case, I will show exactly those two use cases, how we will calculate from the same amount of data, from the same movements, stock information, and the warehouse status. And before we will go to that part, I want to say also a couple of words about our services. So basically what we are going to use, what we will see today. So Azure Cosmos DB, I hope that everyone more or less at least heard about it. For those who didn't hear anything, it's a globally distributed, multimodal, massively scalable database. You can see that there is different APIs supported. It's a table API, Cassandra SQL, MongoDB, and Gremlin for Graph. So by default, there is a SQL API, and I want to say one thing, that for those who never used Cosmos DB before, like small hint or tip, never use SQL API as you would use traditional database, because I made this mistake and I saw what kind of consequences can be out of this. If we're gonna use it as a normal traditional database, we will build the queries. In the end, we will end up complaining the Azure Cosmos DB is extremely expensive and no one, please don't use it. So just remember that it's not exactly the same thing, and we should exactly build those projections and views to optimize our read operations instead of building queries and call them every time and execute them every time when we need to fetch the data. So I don't want to spend too much time on Cosmos DB. I have another session where I'm talking in more details about how Cosmos DB works itself. We go into the next service, so we're going to use Azure Functions. So I will have function up, where I will have different functions to create movements, to call negotiate endpoint with the SignalR service, also to get some stock information, to generate the stock information, and et cetera, et cetera. And again, a couple of words about Azure Functions. Why do I like to use them? Of course, I'm a big fan of normal development, where we build like huge APIs, a lot of code, everything as we like as developers. But Azure Functions sometimes can be very, very useful when we need to build small pieces of code, small bricks, and we want to have a fast development. We maybe have a multi-language environment. It's also fine. Azure Functions supports C# and Java and JavaScript, Python, and PowerShell as well. So also Azure Functions are very easy in the way of deployment. So we don't need to care about anything. We just can publish it, and Azure will take care of the rest for us. And of course, the pricing options, it's serverless, so we pay as we use. And if we not calling our Azure Functions, we would not pay anything. If we made 100 requests, we will pay only for those requests. So this is also a great thing to save a cost, especially when we're just starting. Maybe if you have a small application, it would be the perfect way to go. And the last thing is Azure SignalR. So Azure SignalR, it's a fully managed real-time messaging service. And so what is happening there, our clients basically has an option to connect to our SignalR service through WebSocket. And if WebSocket somehow is not supported, not available, then it will be then another server-sent event will be used, or long pooling instead. And basically, it's kind of just not an abstraction, let's say like this, as a traditional SignalR. It's a service available in Azure and working exactly in the same way. That's fully managed by Azure, and we don't really need to take care of anything. And if I remember correctly, there is like by default one instance of Azure SignalR can support 100,000 connections. So pretty good as for one instance, I would say. And going to our use case. So as I mentioned already, that I was working in a product company. So we were building a system, the monitoring system, warehouse system. We were rewriting it, and our idea was that we can have, for example, in a warehouse, we can have different devices, and then we can scan every time when there is a movement happening. We can scan the articles, and we can scan the location or our shelves, and those events will be stored in Cosmos DB. This basically would be like event sourcing, I would say, because we will have movements. We will just append every movement which is happening there. All our events will be stored in Cosmos DB. What will happen afterwards, then we will react on those changes. We will react on our movements, on the events, and with change feed, we will basically subscribe to a change feed, and we will generate different views from those movements. So in one case, we will have a state of the warehouse, and we will update the view for the specific location. For example, how many articles were moved on this location, or how many articles were moved from this location. And the second use case is we will calculate stock information. So basically, only the location ID or location address, and how many articles currently is on this shelf. And this information, of course, those views, we will write back in Cosmos DB, so we will have our projections, and they will be available for read. What's the actual purpose of doing it in this way? For us, it was very important to be able to easily say if we still have this product, if this product is still available. And for example, we also, when we receive an order, we want to easily find the place where do we have those articles, where do we have those products. So we can basically build an optimized route inside the warehouse, how our pickers can go and take those products. And this information would help us to optimize internal roads, how also the cars, like basically those forklift drivers, can move inside the warehouse, how the employees can pick up some products, and many different things, basically based on the same information, same set of data. We can generate as many projections as we want for different purposes. And this approach gave us flexibility for exactly the reason, as I said. We can generate as many views as we want, so basically those Lego bricks. For every client, for every consumer, for every need, we can just rerun the change feed, pull all the data from the beginning, maybe from the specific point in time, and generate a projection for the clients. So the next step is to actually stock monitoring. So as I mentioned before, we're going to use SignalR, and idea was that we will have a real-time stock monitoring, basically showing what is happening in the warehouse in the current time, in the current moment. And having our stock information already calculated as from the previous example, and the same would be for the state of warehouse. When it was written back to Cosmos DB, we would have the same basically structure. The same, we will subscribe to a change feed, and with the Azure function we will have trigger, and we will react on the update of the projection, and we will say to our SignalR servers that, hey, we have some changes, and then SignalR will basically push this to our clients. And that kind of approach basically introduced for us simplicity, because we don't need to use any other services. We don't need to use we don't need to introduce complexity. We already used Azure Functions. We already know how to use Cosmos DB, how to use change feed. We basically did the same thing we did before, but for the other purpose. And that allows us to very quickly, first of all, for the whole team to learn how to build it, and then independently develop our system without worrying, like, okay, here we need another technology, another library. We didn't care about it because we were using the same things. And moving forward, also for us was a great, basically, benefit, a huge benefit, that Azure Cosmos DB and the change feed, amazing feature they have, has an integration with another Azure services. So we can, as we already showed, that we can use Azure Functions. We can also use Notification Hub or Azure App Service for basically like for notification and event computing. We also can have stream processing, real-time stream processing with Azure Stream Analytics and Apache Spark, Storm, or HD Insights. This was our use case exactly when we were receiving all those movements, when we were calculating what kind of a load on system we would have, because we had around 30 or 40 warehouses for the initial start, let's say, and we wanted to expand. And in every warehouse, there's basically like every second, every like milliseconds, there's happening some events, because basically picker, when he scanned the crate of products, we were generating movements for every bottle of the product, every bottle, yeah, because we were delivering beverages, and it was generating really high load, like a lot of different movements. And if we wanted to see some information, like for example, how many articles, even how many articles we still have in our warehouse, we needed to have real-time processing of this data. And for this, Apache Spark was basically the great service for our use case. So Azure Cosmos DB has under the hood connectors to with Apache Spark. So the opposite. Apache Spark has connectors to Azure Cosmos DB nodes, and in real time can basically calculate and aggregate all this data. And will be much, much faster than we will try. Like, it's also possible with Azure Cosmos DB functions, but it will be much faster with Apache Spark. And also data movement. It's always the same question when we are selecting database. The product managers or like stakeholders, doesn't matter, they all have the same question, like, what if we will decide to use different database? And with Azure Cosmos DB, the great thing that we can easily move our data in any other data storage. It could be the data lake or blob storage, or storage blob or storage table, or the same Cosmos DB. If we'll change our mind in the process, it could be the same Cosmos DB. Because change feed stores the whole history of our changes, all the history of the events from the very, very beginning. So we can easily just pull all this data from change feed and transfer it to another data storage. We can also work with the change feed in a different way. So we can pull the data. It's a pull model. We can also use change feed processor library. It's basically an abstraction on top of this pull model, and this pull is already done for us. And we will subscribe on a specific container. This data will be anytime when there is a change happening, those events will be pushed to us. So we have to specify which database, which container we're listening to. We have to take care of deployment. But this is basically quite pretty easy way to get some data from change feed. But of course, the easiest way with the Azure Functions, we still have to connect to database, specify connection string, and say which container we want to listen to. But it's much easier from the perspective that Azure is taking care of us, for us, of the managing completely the Azure function and how it's happening, how it works. So the function app, what we're going to use is basically we will have our unit of deployment and development, and our function app will have a couple of functions, as I already mentioned, and we will use two types of triggers in our case. One trigger is HTTP, just to call, for example, to trigger creation of the calculation of stock information, or to call negotiating point, for example. And also we will use Cosmos DB trigger to react on changes, to react on movements, and generate our new projections. Also, functions has many different bindings. There could be output and input binding. We will have Cosmos DB binding and SignalR binding. So that's basically how it will look like. I'll show just the usage and combination of those bindings in my code. Then I will also show the rest of the code with the logic. So as you can see here, that for creation of the movement, I will use HTTP trigger, and I will also use Cosmos DB output binding. So what does it mean basically? Then I will say, okay, I received a movement, I received an event, and when my Azure function will finish execution, this movement will be automatically saved to Cosmos DB. So we don't need to create a client, we don't need to add this document, we don't need to call any save data method. We just need to add to this documents our collection, our item, our movement, and when the Azure function will finish execution, it will be automatically sent to our Cosmos DB. The next one is calculate stock. We will have Cosmos DB trigger. As you can see, we will listen to the warehouse database and to the movements container. We also specify Cosmos DB connection, and we have two other properties, which is list collection name is to basically manage the state of change feed between the to sync the state of the change feed between the Azure functions, and also the flag if you want to create this container or not. We also can provide, for example, prefix for this list container if you want to use the same container, but to share it between different Azure functions. We can provide the prefix for the name of this container, and then we can kind of reuse the resources. The next one is to get the storage locations. So this also has a HTTP trigger and Cosmos DB input binding. Basically, here we're going to listen to stock per location. We will connect to stock per location container, and once we will call this function, all the data from this container will be automatically pulled from there, and we can just return it to the client. Here I'm not using any like filtering or whatever, because I want to receive all the information from the container, but we can also after like specifying connection string setting, we can also provide, for example, partition key or ID of the document, or maybe even SQL query, which doesn't look really good, to be honest, in my opinion, but it's possible. I would not, to be honest, recommend doing this, because I think that it will just introduce complexity, and it will be very, very confusing when you will open your code, you see HTTP trigger, and then you see SQL query, and it's like, okay. So I would just recommend to maybe specify a partition query, maybe creating the projections, maybe storage procedure if you really need to do something specific, but do not use SQL queries inside the binding if it's not really, really necessary. So with Azure Functions and triggers and bindings, what was great that we had no need to write all this all this code. We had much less code as a result. So the development was faster, development was much easier, because we don't need to create clients to connect to our database. We don't need to manage to have the whole data access layer, for example. We have no need in this. All the information getting our data, it basically can be done with a couple of lines. And I want to show the rest of the code, so we will now go to a demo part, if I can manage again with the... Yep, great, managed. So let's start from the creation of movement. Can you see actually the code? Oh, good. Okay, great. So the same thing as I said already. I'm using trigger and I'm using output binding. So I'm receiving some information. I could have a query, I could have a body, it doesn't really matter in a request. Then I'm creating basically the movement from the information I received. As you can see here, I'm just generating some random movements because obviously it's just for a demo purpose, but I have some random data for my articles, random data for my locations. I generated this information and just returned the object. Afterwards, when I have this object, as I mentioned already, what I have to do is just say documents out, the collection of my documents with the output binding. I will just add this item, and that's all. I don't need to call any other method to save this information. Once the execution of Azure function will be finished, it will be automatically sent back. Get storage location. Here's a great example, actually. That it's really much less code. We need to basically get the data. I used input binding. I get all the information from my container, and I just return it back. So of course, like some logging, maybe some validation if it's not empty or whatever. But I just like one line of code basically was some attributes and some magic behind it, and we are good to go. So also with the calculation of stock. Yes, I guess that I was showing different. No. Yeah, the calculation of the stock information also is happening with the Cosmos DB trigger. So as I said, we have our movements container we're going to listen to, and here we just deserializing our movements, and basically handle movement changes is basically the business logic, how we going to process and aggregate our data. I moved all the logic away, so it would not distract from the actual flow. But here I have like helper that just groups all the movements, and it will select by storage location, by every shelf where I have, how many movements happened, how many items were added, or how many items were removed from this location. And then it will just give me back the aggregated, already calculated data. And for those three functions, that's basically all. I would not show you the rest yet, because I want to get back to my presentation and try to extend it. Yes. I'm sorry for this switching, just otherwise I would not see what I'm actually showing you. Okay, so that was the part of how we generate movements, how we can calculate our stock information. And now we go to the SignalR connection. So basically now how we can connect to the SignalR, how we can receive the information, how we can work with this. We will have another function with the HTTP trigger and SignalR binding. This needed to receive for our client the service endpoint URL and access token. So this Azure function will be called by our clients. In my case, only one client. This will be SPA application. So I would call this Azure function explicitly, and it will call negotiate endpoint. And I will return back this endpoint URL and access token, which will be used by my client to connect to the SignalR. And SignalR later on will transfer the data and notify my clients that something has happened there. And there is a trigger also, it's basically stock change trigger. So when we received our movements, we calculated our inventory, and we saved back this data. And now we have to notify our clients that, hey, something happened. So in this case, we are going to use Cosmos DB trigger and SignalR binding as well. So we're gonna subscribe to a collection which is called stock per location, and anytime the change would happen, it will use this SignalR binding to add the messages basically to the queue. So it will send the messages to SignalR that, hey, there's something has happened. We can put some data there as well. We can specify to which basically hub we are listening. And it will communicate all the changes basically in real time. But of course, when we are using like free tier and just for testing purposes, it will not be that fast, but still. So this is basically the small piece of application, our client, which I'm using for monitoring my inventory. And I have storage location, which has ID 222, just basically a refilling process. It's a part of refilling step. And I have some items there. So when the change is happening with Azure function, my client will call on the start of the application, my client will call negotiate endpoint, will receive information how to connect to actual SignalR service, and will establish connection by WebSocket. And then Azure function will let SignalR know through the SignalR binding that something happened. So there's going to be communication in a triangle, and then SignalR will then send back those messages with the data. That's how it looks like when we want to connect to SignalR from SignalR service from our clients. So we have, of course, I'm using SignalR library and so on, and I will have hub connection builder. So I need to provide the URL to my Azure function, just /API, no negotiate or something. It's not needed. This library will, on its own, call the endpoint with the negotiate wrote, and we'll get all the necessary basic information. Oops, I'm sorry. All the necessary information for our connection. And then afterwards, then we can start basically connection.start. It will establish connection with Azure SignalR through the WebSocket, and basically our client will be ready to receive some messages. This is how we can subscribe on a specific basically events. We can say connection on and specify the event name. So when there is a change happening for the, for example, movement was created or stock information was updated, we subscribe to it, and then we can provide like basically business logic, how we're going to handle our change, how we're going to handle this message. For my client, I'm using React, and I'm using Mobix State Tree. Is anyone ever used Mobix State Tree here from? No, no one? No one? Okay, great. This is this is very lightweight. Basically, there is Mobix and there is Mobix State Tree. So basically, it's a data structure, a tree structure of our data for the client, and it's a library that helps and simplifies the organization of application state. Of course, in a very, very structured manner. So we basically have a store where related to a specific entity where we can specify how we're going to show our data on UI, so basically views, and how we're going to operate with our data through the actions. And of course, the model itself, it's how our data looks like. So for the UI, for the small applications, for example, Mobix State Tree, in my opinion, is a really nice library because it simplifies and speeds up the development quite good. So yeah, I already said everything why I liked it. But yeah, once more, so it provides centralized stores. As I already mentioned, with the models, with views and actions. Its data is easy to use, but it's protected. So that's actually the good point I forgot to mention. So my data is mutable, but it only can be mutated through the specific actions. So I cannot just call the property on my model, say, and assign it a different value. I cannot do this. This would not work. And this is kind of like encapsulates a bit my data, so protects it. And the last thing is it's normalize my data. So it has a built-in support for references. So I can have a normalized data, and I can basically just reference one store from the different place of my application, and I can reuse already what is created. So I don't need to duplicate it somehow and demo part. So once again, the same magic with mirroring. Great. So going back to my backend, basically, this is how negotiating point looks like in general. So nothing more, one more line beside the actual attributes. So I have a trigger. I got all the information with my access token and URL, and I just return this connection information back. With the stock change trigger itself, it's a bit different. So as I said already, that we're going to send back the messages of what actually happened. So we're going to react on changes in Cosmos DB. We will log some information. We will generate the message. And I will have event called stock per location changed. So basically, that some update happened, or maybe some new articles that were added. And I also will send back the actual input, like all the storage locations that were updated. I will send them back in arguments. And I will just add these messages to the SignalR messages collection. And that's basically all. So they will be sent to the service, Azure SignalR service, and this service will communicate to our clients through the WebSocket that something happened. Going to the client. Oops. Yes, so this is the place what I'm connecting basically to the SignalR service. And as I mentioned before, that I'm using Mobix State Tree. So that's how it looks like. I have a store where I'm describing the model, because this is my store to connect to the SignalR. I don't really have any model there, so the only thing I need to do with the store is just to connect to the service. So my model will be just an empty object, and the actions which that I specified here will be connect to socket and get stream. So it's two actions. With the connection to socket, as I said, I'm going to use SignalR library, and I'm providing the URL to my Azure function, and I'm starting my connection here. So I can also provide some logic how I'm going to handle if something failed, maybe there is problem with some notification, but that's basically up to you how to do this. But the most important line is this one. So we connection.start. And then afterwards, when I want to basically receive the event, subscribe to a specific event, I have an event name, and I'm checking if I already have this subscription or not, because I don't want any duplication, and I will connect to the event. I will listen to the changes, and then I will execute basically. I will process this data. I will use some business logic, whatever I have, maybe just to show on a screen, maybe just aggregate it and show it in a different way, but it doesn't really matter. So the most important that we can react on those events here. And from the UI part, that's all. I want to go back to a portal, not back, but now to a portal, and actually show the Azure function, the function app I have. So this is the function app I'm using for Cosmos, for this demo for Cosmos DB, SignalR with React. So I have functions. All those functions we already saw before, they are listed here. So basically, you can have those functions all together, but also a good way, if there is no specific reason to keep them together, will be better to create different function app for different, for separate function. And I can also trigger them from here, for example. I can run code and test, trigger, and they should work if you provide some data. And with our database, Cosmos DB, here what I have is I have a warehouse database, and as we saw before, I have 3 containers. So we saw already movement container, we saw already how stock per location basically will be created, and this container just for managing state of Azure functions. As I mentioned before, that I had some troubles with the demo itself, so I will go back to my presentation, and I managed to do some screens before. I managed to do some screens of how to actually. Oops, I'm sorry. Not an easy. Oh, great. So I have a couple of screens where I want to show basically what was supposed to happen during the demo. All this code is on GitHub available, so if someone would be interested to actually see how it works, I can run it later on. You can drop me a message. We can do this together. But in general, so this is how the application looks like in general. So there is just 2 buttons to create the movements, to generate some random movements, and start interval should basically simulate that movements are happening in a real time in our warehouse. So basically the collection of movements with a higher load of data. And in our database, there's, of course, at this moment, there would be nothing. And once we will trigger creation of movements, we will start receiving on our UI some information about storage locations. So we will have the storage location and the names of the articles. we will have, for example, minus 1, minus whatever values, and normally, like, it's the question, like, how does it happen that we have the negative value in the shelf? But actually, it's quite easy. Like, this is a real use case. It can happen in warehouse because people can steal, people can break something, the bottle can suddenly disappear, and that's what generates the minus values, basically. And we should handle this. For us, it was also very important to understand where we actually have, when does it happening, and what's the reason for it. And in a Cosmos DB, we will have some documents generated in the movements containers. If you can see, they would look like just a plain document with some information, basically what is the movement, from which location to which location it happened, but it's basically just an event. When we will have stock information calculated, this basically will be aggregation of our movements. So on this location, it's a type, for example, of the step in the process is like picking or refilling or inbound, outbound, doesn't really matter. And we will have different articles. So with basically quantity, the article ID and article name. So that's the only information that will be interested for us. And this is the stock per location. That's the information that our client will receive, and I will be able to display per every location all the information about articles, aggregated information. In the demo, I also like usually I trigger the stock change trigger, basically just to generate some movements and see, first of all, that I can test like this my Azure functions, triggering it from Azure, but also to generate some events and see how the changes are happening in real time. Yeah, that's basically what we were supposed to see with the demo. And I guess that I'm already a bit out of time. So just to summarize it, so with this approach, we managed to have much less code with Azure Functions. We already saw how bindings and triggers can nicely combine, and afterwards we just need to write a couple of lines to actually return the data or aggregate it. We can concentrate on our business logic, so we don't need to take care, like, we had the concern that our developers don't know how to use the Cosmos DB, or our developers don't know how to use some connections to, like, SignalR. But with Azure Functions, doesn't really matter. We can concentrate on business logic, use those bindings, and we don't really, like, our developers don't have a need to actually sit and invest time. Of course, it's great when they learn, but when there is not to slow down, but speed up the process, this is a good way to go. And also, it's introduced us simplicity in building basically those separate components independently, and we don't need to basically be worried that one developer will step on another. We can just provide the same amount of data, same set of data, our movements in a container, and then we can just connect to the change feed, for example, pull this information, and every developer can generate different projections independently and work on it. And that's basically all. Yeah. Once again, if someone have any questions or comments, please feel free to either write me or now if there is any. But I guess I have only like a couple of minutes left because of those problems from the beginning. Thanks a lot for the attention. Sorry for the problems and the troubles with demo. If anything, if someone wants to have code, it will be available on GitHub.